Welcome to myprojectbazaar.com. Our project title: Energy Efficient Infrastructure Sensor Network for Ad-hoc Cognitive Radio Network. Now see the abstract. Cognitive radio is a promising technology for next generation wireless networks in order to efficiently utilize the limited spectrum resources. It satisfies the rapidly increasing demand for wireless applications and services. Also, this network is emerged as an efficient solution to the problem of spectrum scarcity and its underutilization. The development of the CR technology leads to the new communication paradigm called dynamic spectrum access, which relaxes the traditional fixed spectrum assignment policy. In this network, the secondary users exploits the primary users' period of inactivity to enhance their performance, provided that the primary user performance remains unaffected. The sensor network required for the spectrum sensing should be a low-cost network consisting of a large number of spatially distributed sensor nodes equipped with sensing, processing, and communication capabilities. The sensor nodes carry out spectrum sensing by means of energy detection and report the results to the CR, acting as a fusion center. Generally, the cooperation between the cognitive radio users is not easily achieved, in which the spectrum sensing is achieved by the sensor devices. The proposed system uses an energy-efficient network, including the mobile CRs and the infrastructure sensor nodes. The clustering technique is used for this approach, in which a mobile CR is acted as a cluster head and the sensor nodes surrounded by the CRs are act as the cluster members. Finally, the simulation result shows that the proposed system achieves high energy efficiency and it provides effective spectrum sensing. Let's see the flow of our process. First, the network has to be formed. This network is formed by the number of sensor nodes and the cognitive radios. After that, the cluster is formed. This cluster has the sensor nodes as the cluster members and the cognitive radios as the cluster head. This cluster formation is done by these two techniques, that is J-request and the advertisement. These two are the messages in which the J-request, that is join request message, are sent by the sensor nodes to join the cluster, and the advertisement message is sent by the cognitive radios to join the sensor nodes into the cluster. If after that CR moves in the network, means the cluster have to be updated. So if the CR node is moved, then it updates the cluster with the nearby sensor nodes by process again the J request and the advertisement message. After that, the energy consumption is processed for all the sensor nodes and also the cognitive radios in the network. It is done by the setup and the operation stage. Finally, the transmission is done, that is the sensor nodes transmits the sensed data to the cognitive radios to provide the spectrum availability. Finally, the performance is analyzed for our proposed system. Let's see the running procedure. First, open the terminal window and go to the directory where we have the code. Then type in as space file name .tcl. Here 104 nodes are created in the network, that is 4 for the CR network and 100 nodes are the sensor nodes, which is specified in our process. Here, at each and every simulation time, The position and the energy is updated for all nodes in the network. The updated energy, that is the consumed energy, are updated here. Now you can see that for each CR in the network, the available sensor nodes are printed here. After updating the CR, that is if the CR moves means the cluster members, that is the sensor nodes, are also updated. So now we can see the updation here. To see the output, type NAM. You can able to see the network animator window. So open the file, choose the file and click open. This is the output window, maximize it, and these are the sensor nodes and the cognitive nodes in the network range. To run the simulation, click the play button. Set the simulation time, choose run in milliseconds. We can speed up the simulation process here. Here the CR nodes are created in the network. These are the CR1, CR2. Four cognitive radios are created, and these are all the sensor nodes which are deployed in the network. These are the infrastructure sensor nodes. And here the pink color nodes are the cluster members for the each CR. This is the node that generates data which wants to transfer it to the CR network. If one CR cluster is perform communication means the other CRs are in the sleep state. According to the scheduling process, the transmission is performed. Now all CRs are in sleep state. Now a CR node moves in the network to another location. If it placed in another location means the clusters are updated and the nodes are created for the specific cluster. Also, the another CR is moves means these cluster members are move away from this CR, and the new cluster members are created when it is placed in a new location. In that location also, yes, the sensor node is generates data and it transfers to the CR. After this process is completed, we see the performance results in graph. Now the simulation is ends. So close the window and back to the terminal window, then type xgraph graph name .xj. This is the delay graph in which the number of nodes are varied and the delay is calculated for the nodes variation in the network. The XP system have higher delay, but our proposed system reduces the delay. To see another graph, type xgraph graph name .xj. This is the energy graph. As same as the nodes are pointed in x-axis and the energies are pointed in y-axis. The system spends higher energy, but the proposed scheme reduces the energy consumption of the nodes in the network. Hence, overall performance is increased for our proposed system. Thank you.